We humans have always been fascinated by intelligence. For centuries, we dreamed of building machines that could think like us. Now, with the rise of artificial intelligence, that dream is becoming a reality. At the forefront of this revolution are large language models, or LLMs. These AI systems are rapidly changing how we interact with technology and the world around us. LLMs can generate human-quality text, translate languages, write different kinds of creative content, and answer your questions in an informative way. They are already being used in a wide range of applications, from chatbots to search engines, and as these models continue to evolve, they will have a profound impact on our lives. Imagine a world where you can have a natural conversation with your computer. Imagine a world where machines can understand your needs and respond accordingly. This is the promise of LLMs. But how do these language models work? What are the building blocks of these seemingly intelligent systems? Let's delve into the fascinating world of LLMs and explore their inner workings. At their core, LLMs are sophisticated algorithms trained on massive amounts of text data. They learn to identify patterns and relationships in language, allowing them to generate text, translate languages, and understand and respond to your requests. Think of them as incredibly fast learners that can absorb information from millions of books and articles in the blink of an eye. But LLMs are more than just parrots mimicking human language. They possess an uncanny ability to grasp the nuances of language, including context, tone, and even emotion. This allows them to generate creative text formats like poems, code, scripts, musical pieces, email, letters, and answer your questions in a comprehensive and informative way. Their power lies in their parameters, which are the values that control the behavior of the model. The more parameters an LLM has, the more complex and nuanced its understanding of language becomes. Some of the most advanced LLMs today have hundreds of billions, even trillions of parameters. Another crucial aspect of LLMs is their context window. This refers to the amount of text the model can consider at a time when processing information. A larger context window allows the LLM to understand long-range dependencies in text and generate more coherent and contextually relevant responses. To process language, LLMs break down text into smaller units called tokens. These tokens can be as short as a single character or as long as a word. By analyzing the relationships between tokens, LLMs can understand the meaning of text and generate new text that is grammatically correct and semantically meaningful. In the next section, we will unravel the process of building these language behemoths, step by step. Building an LLM is a complex and resource-intensive endeavor. It requires a deep understanding of machine learning, natural language processing, and software engineering. The process can be broken down into several key stages. First, you need to determine what you want your LLM to do. Do you want it to generate creative stories, translate languages, or answer questions in a specific domain? Clearly defining the use case will guide the entire development process. Next, you need to select the appropriate architecture for your LLM. This involves choosing the type of neural network, the number of layers, and the activation functions. The choice of architecture will depend on factors like the complexity of the task, the available computational resources, and the desired performance level. LLMs are data-hungry beasts. They need to be trained on massive amounts of text data to learn the intricacies of language. This data can come from books, articles, websites, code repositories, and other publicly available sources. Once collected, the data needs to be cleaned, formatted, and pre-processed to ensure its quality and consistency. This is where the magic happens. During training, the LLM is fed the massive data set, and its parameters are adjusted to minimize errors and improve its ability to generate accurate and coherent text. Training an LLM can take days, weeks, or even months, depending on the size of the model and the available computational resources. Once trained, the LLM needs to be rigorously evaluated to assess its performance. This involves testing the model on a variety of tasks and measuring its accuracy, fluency, and coherence. Based on the evaluation results, the model can be further refined by adjusting its parameters, adding more data, or modifying the architecture. Building an LLM is an iterative process that requires constant experimentation and refinement. Section 4. Transformers, the engine of understanding. At the heart of most modern LLMs lies a revolutionary technology called transformers. These powerful neural network architectures have revolutionized the field of natural language processing, enabling LLMs to achieve unprecedented levels of performance. Transformers excel at capturing long-range dependencies in text, meaning they can understand the relationships between words that are far apart in a sentence or document. They achieve this through a mechanism called attention, which allows the model to focus on the most relevant parts of the input when making predictions. Imagine you are reading a book. As you read each sentence, your mind automatically connects it to previous sentences and paragraphs, building a coherent understanding of the story. Transformers work in a similar way, using attention to track relationships between words and phrases across long stretches of text. This ability to understand context is what makes transformers so well suited for language modeling. They can learn the subtle nuances of language such as humor, sarcasm, and metaphor, which were previously beyond the grasp of traditional language models. The development of transformers has been a game-changer for LLMs, paving the way for the creation of highly sophisticated language models capable of performing a wide range of tasks. Section 5. Training the Language Colossus. Training an LLM is like teaching a child to speak and understand language, but on a much grander scale. It involves feeding the model massive amounts of text data and using sophisticated algorithms to adjust its parameters, enabling it to learn patterns and relationships in language. One of the most common training techniques is called supervised learning. In this approach, the model is presented with a series of input-output pairs. For example, it might be given a sentence in English and asked to translate it into French. By comparing its output to the correct translation, the model learns to make better predictions over time. Another technique is unsupervised learning, where the model is not given explicit input-output pairs. Instead, it is tasked with finding patterns and relationships in the data on its own. For example, it might be given a large corpus of text and asked to cluster similar words together or predict the next word in a sequence. Training an LLM requires enormous computational resources. The process can take weeks or even months, running on clusters of powerful computers. The cost of training these models can run into millions of dollars, making it a significant barrier to entry for many researchers and developers. Despite the challenges, the results of LLM training are nothing short of remarkable. These models can generate human-quality text, translate languages with astonishing accuracy, and answer complex questions in a comprehensive and informative way. Section 6. The Future Shaped by Language. LLMs represent a profound leap forward in artificial intelligence. They have the potential to revolutionize the way we interact with technology, access information, and even create art. As these models continue to evolve, they will reshape industries, enhance our creativity, and redefine the very nature of human-computer interaction. Imagine a world where you can converse with your computer as easily as you would with a friend, asking it to write you a poem, compose a piece of music, or explain a complex scientific concept. Imagine a world where language barriers are a thing of the past, and you can communicate effortlessly with anyone in the world, regardless of their native tongue. The future possibilities of LLMs are limited only by our imagination. As we continue to unlock the secrets of language and build ever more sophisticated models, we are entering a new era of AI. One where machines can understand and generate human language with astonishing fluency and creativity. The future is here, and it speaks our language.